Yeah. Okay, so our next speaker is David Lovelace. He's going to be talking about geospatial data analysis for heritage and habitat. So David has a background in physics and telecoms, and he's been using GIS for habitat survey and conservation, archaeology and land management since the mid-1990s. We're going to hear from him how tools such as QGIS, PostGIS, aerial photography and scanned historic maps are being utilized in his work.
Okay. So, am I audible now? One sec, there's a process. There we go. How about that? Yeah. Okay, here we go. All right. Yes. So yes, I'm currently working on a number of contracts with Natural England and Herefordshire Council on their nature recovery strategy. So quite a lot of, and I also work with archaeologists and landscape historians. So I'm particularly concerned with the relationship between present day biodiversity and landscape history. So I do quite a lot of georeferencing of historic maps and aerial photographs. So here's an example. Tide map, and that's the so we can carry on through time up to the present, and everything's georeferenced. And these days you can do it accurately to within a few meters, so everything lines up with everything else. So even if you have a historic map, for example, and the scale is, say, 20 chains to the inch and north is up that way, you can georeference it to the modern grid to within a few meters, so everything lines up, which is all good fun. And then I also processing the raw LiDAR files, which are now completely free for anybody to download and process as they wish. With all that, but also there is the raw data. So this, for example, is a photograph of an original apportionment survey of the 1840 tithe survey of a particular parish. And the tithe survey involves a very good map, which can be georeferenced, but each land parcel within that map has a number, and each number gives you the owner, the tenant, the land use, and the name of the parish, because it was an ecclesiastical tax. So I had to work out which parishioner could pay the local vicar however much. Okay, so in terms of, and because it has land use, you can color code it in GIS. And this particular example is looking at the ancient woodland inventory revision for Herefordshire. Okay. So with a tithe map, you can sometimes work out not just woodlands, but you can also work out things like wood pasture. And the most recent definition of an ancient woodland now includes wood pasture and parkland and even small collections of the veteran trees. So that's quite a geospatial challenge. So just homing in on one particular compartment, on the tithe map, it's actually called coppice pasture. So it's a mixture of trees and pasture. Again, we're talking about 1840. Okay, and actually there is the actual there is that actual wood as it is now. And in fact, when I went in, lo and behold, there was some ancient woodland indicators, namely lime trees. So all of that is also very good. Currently working on the history of Pembridge, which is a parish in Herefordshire. And, oh, I've got a note here that I must do that. Hang on, there we are. So this is the village of Pembridge, and this is in, now this is GIS live here, so hold your breath, everybody. He says, putting his glasses on. So that's the, so basically, so this is the current aerial photography, which of course is very high resolution these days. For Herefordshire, this was flown in 2021, but you can see individual trees and all that kind of thing. So we can kind of switch that off for a minute, and let's. So this is the first edition Ordnance Survey, 25 inches to the mile, that was surveyed in the early 1880s, and that's particularly useful because it plots every single significant tree, and of course you can actually georeference it accurately. And if there is a veteran tree, chances are it was there and is there now. However, what's particularly interesting is the tithe map, which I have, this is a copy in the National Archives, which I went up and photographed. There we are. So that's the tithe map. And although it takes quite a long time, I have actually manually digitized every sort. Come on, wrong one. That's it. So I've manually digitized every single compartment. It took ages, but actually in QGIS, it's very doable. And if you look at the, I think I've got that activated now. Yeah. So if you just look at a compartment. Bonk. So therefore, I've now, so you can then establish a database, and it's got the owner and the tenant and everything else, and even the tiny little, these little things which are actually remnants of medieval strip farm systems, which by the 1840s was still current, and they even had their own ownership. Whoops. No, I didn't do that right, did I? Never mind. But anyway, you'll have to take my word for it. Yeah, there we are. So even every single tiny little strip had its own owner, its own tenant, it had a name, it was associated with a particular farm, and all of that. So that's all good fun. So that's what you can do with historic maps, with historic data in QGIS. So going back to the presentation, ooh, and I'll whiz through this now. Now then, that is the those are the little strips before I'd digitize them, and they're still called the Manley Field even now. But what's interesting, if you look at the modern LiDAR scan, even though that's been ploughed and it's just permanent pasture and sometimes arable, the LiDAR, if you amplify the height variations, you can actually see the signature of the original medieval strip farm system that was mapped on the tide map. And so I use this quite a lot. And then in QGIS, you can do a mathematical manipulation of the raw LiDAR, of the raw data to amplify the slope. So slope amplification effectively. So there's another example. It's called Long Meadow now, next to the River Arrow. So this is a floodplain meadow, which I've done quite a lot of work on. And that's just the ordinary aerial photograph of it now. But again, if you look at LiDAR scan, you can see the evidence as, paleofluval, natural, but you can also see evidence of probably old water meadows systems and all that. So it's quite revealing. So it's a mixture of archaeology, landscape history, and present day biodiversity. So in terms of, and then I'm interested in the woodlands, so that happens to be a part of a woodland. And then some tide maps will actually depict individual trees. Another set that's quite important is the immediate post-war aerial photography. And that's what it is now, homing in on it a bit. Comparing the 1800 first edition ordnance survey, which again plots all the individual trees. And that's the and then that's what it is now. And all those individual trees, but they're all lime trees, ancient woodland indicators. So, as an example of starting back in time, going forwards in time, and that's what it is now. So actually, there's quite a change just in the last. That's 2000, and that's 2021. So those trees. Those boundary trees, actually derive from an early Victorian wood, which may well be earlier than that. So, historic woodland now includes quite small groups of veteran trees. And this is where the arrow is pointing, is just on the main road. And I just happened to be driving to Worcester from Hereford and just say, oh, that's interesting, all those trees. So I stopped the car, photographed them, and I thought, blimey, that's interesting. I wonder if they are historic or not. So does that classify as a new recorded ancient woodland on the Natural England National Database? And look at them, they're wonderful. But yes, it does, because they are all there in 1886. And that's what they are now. And you home in on it. And the UKGB aerial photography is so good that you can see individual branches in trees, which is very useful for my project. Similarly, again, if you're classifying so going back in time, again, you can see the individual trees as they are now, as they were, all lining up, and that's it now. Okay. Whizzing through, I'm probably, how are we doing? 5 minutes, that's nice the time. 5 minutes. All right, then, okay, I thought I was almost done. Oh, well, in that case, I'm going to go back. So, there we are in 1880. There it is now. So, quite a lot of the trees that were mapped in 1880 is still there. And then homing in on it, looking at the individual trees, you can see the branches, there they are on the ground. And how about that? So that will become a new, in fact, they're not actually calling it ancient woodland anymore. In fact, the word woodland was only there because in the 1980s, when the very first ancient woodland project, the so-called Broadleys policy, where the Forestry Commission was asked to protect what Oliver Rackham called ancient woodland. Of course, it had to be what the Forestry Commission would regard as a woodland. But of course, now they realise that completely excludes parkland and wood pasture. So it's now called long-established woodland, even though it doesn't have to be woodland. Anyway, there we go. So this happens to be Mockers Park, which is a national nature reserve, and they're very worried about the rate of loss of the oak trees, mainly due to various there's various disease. You've got oak crown dieback, and there's currently a project being actually carried out by the Forestry Commission. So they were asked me to do a sequence, to do a time sequence to see how fast the oaks are actually declining. So this is 1999. So, but this is now, and you can see they have declined quite a lot. Again, if you really hone in on it, you can see how, you can see that quite a lot of trees have actually died back quite a bit. The other thing, of course, is the mobile phone, which allows citizen science projects. Anybody with a mobile phone, as long as they've got their they go into settings and they make sure they've got location enabled. Of course, every photograph you take will have longitude and a latitude at the quality of the GPS chip in your mobile and the constellation of satellites on the particular day that you have to be out there. So one of the things I had done quite recently is a hedgerow survey for the parish of Colwell. And I just used nothing but a mobile phone and a surveying rod, so that people could actually measure the heights of the individual hedgerows. So there we go. And this is part of the presentation I did to try and encourage local people in Colwell to go out and do this themselves and continue work. So of course, when you import from a mobile phone, of course, it should have longitude and latitude on there. Also, mobiles are quite good, and if you go into macro mode, you can do this. You can do the species composition. You can even record individual butterflies. Not only that, but I was actually doing a grassland survey, and you can really home into, or if you're doing a moth trapping survey, mobile phone will be as good as even the very best consumer digital cameras of 20 years ago, which is what I used to use. And I'm also recording the trees, and then there it is. They're all the information in GIS, and you can sort of click on the thing, and there's the picture, etc., etc. In fact, all of that is now actually on the Colwell Parish Council website now. Boom. And if somebody, and then if you want to look at the species composition of an individual hedgerow, there they all are. Now, this is coming to the end now. Now, I have tried to put all of this lot online, but I have to confess I have failed miserably. In fact, when I first agreed to do this presentation, I thought, wouldn't it be good to actually have a working website and everybody in the audience can go onto their mobile phone, there's such luck. But I have tried. So there's GeoServer, and I've got a dedicated Ubuntu server web host. So I thought, that's good. And I've tried using Tomcat, which is what the GeoServer, if you read the GeoServer documentation, they say, oh yes, we've tested it all on Tomcat. Can I actually get Tomcat to function? Even before I uploaded the WAR file of the GeoServer, no. But maybe that's just me. I've only done it. I only tried in the last few days. But on the other hand, GeoServer 3 is about to come out. So maybe that'll make me easier. So I was particularly interested in the previous talk. So there we go. Okay. Oh God, lots of difficult questions. Oh dear.
Brilliant. Thank you very much, David. This is what I love about FOSS4G, is the fact we can go from front-end dev directly into ecology and stuff like that. So any questions? Oh yes.
And David, lovely to see such an interesting talk. My name is Rebecca. I'm an archaeologist masquerading as a GIS. Oh, hello. It has to be really close, doesn't it? I'm Rebecca. I'm an archaeologist masquerading as a geospatial professional here, and I do a lot of work with LiDAR and local communities. So lovely to see that represented. One thing I was just going to ask: have you considered using the relief visualization toolbox for your LiDAR analysis? Just because it's got quite a lot of different.
Sorry, open.
The relief visualization toolbox for your LiDAR analysis.
I'm aware of it. Yes, I did. I did use that. Yes, and you can code, and in Python you can actually code the data set. So that is, I did use that. Yeah.
Just because, I mean, it would be considered to be the industry standard for landscape analysis of microtopography, which is what you're aiming for with the former field boundaries and the plan.
Yeah, well, thanks for that. I mean, I probably haven't used it enough, but thanks for that. It is noted.
You mentioned that you've done some processing to the LiDAR data to better emphasize the slopes.
Yes.
What sort of processing was that you did?
Well, basically what you do is, okay, all right, okay. So you basically deliberately blur because basically, as you know, a LiDAR, the raw LiDAR file is just basically a text file of numbers, effectively, with lots and lots of heights and obviously the geolocation of each height. But then you've got to convert it into a 3D surface, all right? So once you've got the 3D surface, then what you've got to do is you've got to amplify the slope, okay? So basically what I do, and this may not be the right thing, and somebody else may say, or maybe the plugin does this for you, which I haven't tried. So basically you blur it and then you subtract from the blurring, you amplify anything that's a slope, you multiply you increase the height dependent on how much slope there is. So if it's flat at the top, it's 0. And if it's, let's say if it's 45 degrees, that's, you multiply it by 100, subtract that from the, basically from the blurred version. And so all you've got, which you've just seen, all you've got is just basically a color-coded slope map. So if you've got ridge and furrow, or even a deserted medieval village, or conceivably even a Roman road, although what I keep on saying to archaeologists is LiDAR's lovely, but if you want to look at below the surface, you've got to have geophysics, or what Time Team annoyingly calls geophys, if you remember those series.
Thank you very much.
Brilliant. I'm going to move on. Thank you very much, David. If anybody has any pointers about GeoServer and Tomcat, I'm sure David would appreciate that at lunch.